Hi, everybody. Welcome to Cadio's webinar series. It's great to see you all. As people are joining, I'll just say that we're happy to have you all here. This is new recommendations for decision-making in MOST that I will be presenting. I want to start by emphasizing that one of the hopes for this webinar is that we will have even more than the usual amount of time for questions. I encourage you to submit questions in the chat whenever they may come up. Kate is going to field those questions if needed, and we can always pause partway through, even if it's a little clarification or something like that. But we have experts in the room, we have experts on Zoom, so this is a great time for questions related to decision-making. And I'll, of course, start by kind of providing a pitch for our newest recommendations. First, some bookends for this webinar, a key idea. Decision-making in MOST is an active research area. So that means that the state-of-the-art, what's recommended, is continually building, evolving, growing. So I just want to start and then, as you'll see, end with the recommendation that you stay tuned and keep your eye on the space. Cadio can help with that in communicating new developments, but this is a very active area, so things are changing. Today, I'm going to give something of an overview of the state of the art as of right now. I'll begin with a brief pitch. I'll then go into the key steps in decision making. I'm going to introduce a methodology we're calling DAVE, and then I'm going to highlight a few bits of new research and also look forward to 2 more webinars in our spring series that this webinar is intended to sort of set the stage for. And then, as I said, we'll have plenty of time for discussion and questions. So without further ado, we frequently emphasize 2 key pieces of the mission of intervention optimization using MOST. The first of these involves building a coherent and ever-growing base of scientific knowledge, for example, about components, what components seem to be working on what outcomes. A second, and of course related piece, is leveraging this knowledge base to identify high-impact interventions. When we're talking about decision-making, we're drawing upon both of these pieces, but we're especially emphasizing this one. So the decision-making involved in identifying high-impact interventions. Of course, there's a lot of decision-making in intervention optimization, but to just be very specific here, when I say decision-making today, I'm really referring to the decision-making that goes into choosing an optimized intervention based on the empirical results of an optimization randomized control trial, which I might sometimes refer to as an ORCT. Now, standard practice with 2 to the k factorial ORCTs, as we're working to add to that scientific knowledge base, we estimate main effects and interaction effects. And these can communicate really important information about the components that we're considering and which components might demonstrate evidence of being active. So for instance, we might find that the factor for component A has a main effect in the desired direction. We might find that the factor for another component, component C, has a main effect in the desired direction. We might find that the factor for still another component is involved in a synergistic interaction with the factor for C, and so on. And this sort of information really helps us paint a picture of the activity of these various components on our outcome or outcomes of interest. When it comes to then selecting an optimized intervention or making a decision, we have to use this information. And frequently, we're not just using this information, but we might also be using information related to the strategic balancing that we want to carry out for our optimization objectives. So we might be using information about the cost of each version of the intervention or the amount of time that a particular intervention version requires. Now, while it might be possible in the process of building scientific evidence sometimes to conclude that there is insufficient evidence to support X, Y, or Z, there really isn't a perfect analog to this in decision making. You either choose an optimized intervention, one of various, to move forward with, or you choose no intervention to move forward with, and therefore even doing nothing is a decision. And if you don't want to take my word for this, I like to bring up someone far wiser who says much of the same thing. Now, as we shift into the selecting an optimized intervention mindset, our thinking also changes a bit. So now we're thinking, what intervention composed of some combination of components seems to best accomplish my objective? And maybe is what this intervention accomplishes worth it? Now, that type of thinking is really about the expected outcomes associated with our different intervention versions. And I'll just say again, when I say intervention versions, I mean different possible versions of the intervention composed of different combinations of the candidate components. And what we're really thinking is which of these different versions can be expected to accomplish the best outcome. Now, a quick technical note here, this obnoxiously long equation here includes terms for main effects, for interaction effects, all the way up to the four-way interaction effect. If this looks familiar to you, you might have thought some about how we estimate y-hats using the empirical information from 2 to the k factorial optimization RCT. This is just emphasizing that how we get to an expected outcome is using the empirical information from the ORCT about these different main and interaction effects. So we can then identify key steps where the first step involves estimating individual main and interaction effects. Like I said, this is key to the knowledge base, that process of building a knowledge base, but also to really understanding what the evidence is suggesting from the factorial ORCT. A second step then is to identify and interpret important main and interaction effects. And in my latest thinking about this, I think about this as sort of looking through what might be many main and interaction effects and identifying any that are of a particular magnitude and interpreting them. So understanding what that main effect, for instance, might mean for a particular factor representing a particular component. A third step then is estimating the expected outcomes, those y-hats. This can be done in various ways. Our recommendation involves what we have referred to as a posterior expected value approach, but this is just a matter of estimating those y-hats. Then we can use those expected outcomes to identify the intervention that best accomplishes the optimization objective. This might be as simple as identifying the expected outcome that's largest, assuming that larger is better for an intervention. It also might be, as we'll talk about in just a minute, a matter of strategically balancing the effectiveness that's communicated by the expected outcomes with something else, cost in dollars, cost in time, and so on. And then I think there's an important additional step here of then using the information from the main effects and interaction effects as estimated in step 1 and then further understood in step 2 to better understand and or even potentially reconsider the choice in step 4. So This step is one that I'll just highlight as a step that we are very actively thinking about. I recognize that there are some complexities here when you bring together information from expected outcomes and information from main and interaction effects. But to give two concrete sort of examples, I might have a particular intervention that emerges as having the best expected outcome. And then when I look to the main and interaction effects, I can see a little bit of the story as to why. So for instance, if the intervention that is performing best contains components A and B, it might be useful to me to see that A, for instance, has an important main effect, and B appears to be involved in important synergistic interactions. It can be useful to have that further understanding. As a second example, if I find that the intervention with the best expected outcome is intervention AB, but I find that there are no significant main and interaction effects detected in steps 1 and 2, that might also be important information for me to know that the expected outcome that I've estimated doesn't necessarily contain components that meet that earlier threshold for being active, and that's something to think about in the decision-making process. So I just want to emphasize that this isn't a matter of estimating expected outcomes, picking the one that's best, running with it without thinking any further. There's always continual thought here. And if this is something that there are questions about, I'll emphasize again, there's a lot of active thought in this space, and it's something we could talk about more. I'll pause for a moment. Next up, I can give a brief example of this, but if there are questions, clarifying, whatever, feel free to raise your hand or put one in the chat. All right, so I'll proceed with an example, and again, just to reiterate, if questions come up, feel free to input them at any time. This empirical example is drawn from some work that our colleagues did in optimization of a chatbot that was intended to promote service use among individuals who screened in need of treatment for eating disorders. And I'll also say that Dr. Fitzsimmons-Kraft, who is the principal investigator of this line of work, gave one of our webinars in the recent months, and that's available on Cadio's website if this particular example is of interest. But just a quick example of what it might look like when we estimate main and interaction effects. In this case, this example is a 2 to the 4th factorial optimization randomized control trial. And so there are 4 main effects that are estimated, some 2-way interactions, 3-way interactions, up to 1 4-way interaction. And these are just depicted visually. This is a higher is better treatment seeking outcome. So next step might be to identify and interpret important main and interaction effects. I've highlighted this one. So the factor for what I'm calling component D here has what we would consider an important main effect on this particular outcome, suggesting that effect on the outcome on average over the levels of the remaining factors. We can then estimate expected outcomes. These are now presented in terms of the different possible versions of the intervention. The minimal version, where everything is set to the lower level, to the full, complete version, where everything is set to the higher level. Again, this is an outcome where higher is better, so higher, larger y hat is implying a better performance. So then we can use these to identify the intervention that best accomplishes the optimization objective. So if it's as simple as identifying the intervention with the best expected outcome, that might be this one, the intervention that contains components A, B, and D, which has the largest expected outcome. But then to use the information from main and interaction effects to better understand this, for one thing, we might note that the intervention that contains A, B, and D does contain D. That was that one that had the important main effect in the desirable direction, so that might not be surprising. I've also included a little highlight for the intervention containing only D, which does not, according to these results, have as large an expected outcome as the intervention that also contains A and B. That could be due to some synergies among A, B, and D.
Before you
Yes.
get into Dave and introduce us to that, maybe you could go back one.
Yep.
Could you discuss how these steps relate to decision priority and conclusion priority?
Absolutely. So for anyone who might not be super familiar, we frequently talk about a difference between the conclusion priority perspective and the decision priority perspective. And I'll just put the full list up here again. So the distinction between these two perspectives can sometimes have a little bit of gray area, but if we think of the extremes, a conclusion priority perspective is focused on making a scientific conclusion that meets the expectations of scientific court, so to speak. Whereas a decision priority perspective is oriented more towards making the best possible use of the available evidence to make a decision sort of from the Yoda perspective of we do or do not, and we're going to try to make the best decision we can. The first step of estimating main and interaction effects, and the second step in particular, identifying and interpreting important main and interaction effects, in general, fall a little bit more under the conclusion priority perspective, where we are applying the sort of expectations of science court, which might be a statistical significance threshold, for instance, to say what large magnitude main effect is. Or it might not be statistical significance, it might be clinical significance, an effect size, but we're hoping to draw a conclusion about which components are active, and in what way. As we get to the later steps, especially step 4, this is a step that falls more under the decision priority perspective. So making use of the available information from the optimization RCT to identify the optimized intervention. Step 5 sort of very carefully integrates some of the thinking of a conclusion priority perspective and a decision priority perspective, but really aimed at the decision that's made. So I might include that within a decision priority as well. Would you, Kate, agree with that?
I do, and I just think you did a great job of summarizing a whole other webinar very quickly there. So I dropped the link for the webinar that we did in the fall about decision and conclusion thinking. Did that answer the question? Okay.
Great. I'll now turn to Dave. Decision analysis for intervention value efficiency. This has been developed in collaboration with a number of colleagues, but including Dr. Linda Collins and Dr. David Van Ness. I haven't confirmed, but I think Dr. David Van Ness might be here with us.
So is Chuck.
And, oh, great. And Dr. Chuck Cleland is also here with us, members of this particular team involved in this paper. I also will put it formally on the record that the name for decision analysis for intervention value efficiency is a fairly obvious homage to Dr. David Van Ness, whether he wants that to be true or not. So I'm so glad that he might be here. But anyways, If you'd like to read about this in detail with this team, we have this paper in Health Psychology. But what Dave, the method, is in a nutshell is a strategy for identifying, based on the empirical results of an ORCT, interventions that accomplish intervention ease. So balancing effectiveness with additional criteria, affordability, scalability, and efficiency. And in particular, in that name, Dave, we have this term value efficiency. It's a somewhat complex one, but to summarize it as in the simplest way I can, an intervention is value efficient if it is expected based on those empirical results of an ORCT to produce the valued outcomes without resource waste. So I'll get into a more concrete example of this as an illustration using the same example from before. One of the primary outputs of Dave is information like this. So in a plot like this, we have a dot for each of those intervention versions. So recall there are 16 versions in this example, from the minimal version, min, that has every factor set to its lower level, to a complete version that has everything set to its higher level. The placement of these dots is a function of their expected value, that's on the x-axis, and their time or any other constraint. But in this particular example with the chatbot, I've used time as the limiting constraint given the need for engagement on participants' parts. Now, I want to emphasize here that I've sort of seamlessly transitioned from thinking in a single outcome sense, treatment seeking as our outcome, to a multiple outcome sense. The methodology here, Dave, can readily accommodate one outcome or multiple outcomes. In this case, I've chosen two. So we have a treatment seeking outcome, but we also have a helpfulness outcome where participants indicated how helpful they found the chatbot to be. Now this chatbot, or the helpfulness outcome, was treated as half as important as the treatment seeking outcome, and that's where those weights come from in the little formula there that's communicating how expected value was calculated. So if there are questions about multiple outcomes, we can talk more about that. For now, I'll simply say that we have the empirical information about each of the individual outcomes that has been combined using this really simple value function to produce one measure of performance, expected value, for each intervention. And then, as I mentioned, on the y-axis, we have the constraints. So the orange dots that you may see as separated from this solid line are interventions that are dominated by the green ones, or the ones that fall on the solid line. And they're dominated because other interventions that could be considered are more effective and take less time. So one way of thinking about this is that according to the evidence from this particular factorial ORCT, the green dots might be preferred to the orange dots. Now, the intervention that contains A, B, and D, as it was in the single outcome version of the example, is the intervention that performs best. It has the largest expected value. But one thing that emerges from results like these is that the intervention that contains C and D performs very similarly. And I say it emerges from results like these, meaning you can certainly see that if you look through the table of y-hats as well. This is not necessarily new knowledge, but this XY scatter plot really illustrates this. So one finding here is that intervention CD performs very similarly to intervention ABD and takes considerably less participant time. So using Dave, a team of intervention scientists might think through this decision, taking into account both of these dimensions. And it might be that the team would decide to move forward with the intervention CD here, given that performance relative to the cost. I'll pause here again to see if there are questions or clarifications at this point.
Yeah, I have a question. Like,
Great.
why I'm married.
Hi.
So my question is why CD intervention is selected based on like it is quick, that's why, or it is more effective?
Yeah, good question. So in this particular case, the intervention ABD is more effective according to these results or these estimates here. It's the estimate for ABD is larger than the estimate for CD, but not by much. In fact, the difference between the two is very, very small. And so the decision might be CD in this case, because there's such similar performance that they might really be equivalent in their performance, and CD takes less time. So it might be the quote unquote safer bet. But one thing about using results from Dave is that the methodology doesn't necessarily say this is the decision. It more presents the results, and a team of intervention scientists would have to think this through and decide, would we want to go with ABD as the optimized intervention or CD or something else?
Okay. Thank you, Professor, for
You're
answering the
welcome.
question.
Sure.
Hi, Professor. I have two questions. First question is, does this model consider multiple decision makers? And secondly, does it incorporate multiple level of analysis?
Great question. So first, to start with multiple decision makers. As far as the Dave methodology, this output could of course be presented to multiple decision makers for a group to come to a decision. That is not something we have devoted a lot of attention to just yet, other than with the understanding that a lot of times when teams select an optimized intervention, there's more than one person on that team. And so in practice, that is frequently something that goes into selection of an optimized intervention, but we have not gotten into detail about what it means for different decision makers in a room to have different preferences or to have different ways of thinking about these constraints. And that's one of the reasons that this is such an active area. That's certainly a priority to think about. And then so as far as the levels of analysis, can you tell me more what sort of levels you're thinking about?
I was just wondering, like, if there is an intervention regarding smoking cessation among teenagers in underprivileged sectors of the city. Like, there are multiple outcome variables, multiple decision makers, I mean, non-normal models and multiple level of datas involved. So how are all these variables and outcomes analyzed? Are they analyzed segment by segment and then all the data is put into it? Like, I meant that kind of multiple level of analysis.
Got it. Yeah, you've done an excellent job of setting up really key important areas for further work. And what you describe is another one, because we have so far gone about this with outcomes that are measured at the same level. But there would certainly be potential to apply this sort of methodology with outcomes measured at different levels and with the sort of complexity you describe. That's another really important direction for future work and thought.
Thank you so much.
Thank you.
And is it just maybe worthwhile to reassure that you can do a factorial experiment that has levels and clustering?
Yes, absolutely. You can, when there's clustering, you can do a factorial optimization randomized control trial. There are some additional complexities involved, but you certainly can do it. And you could apply these decision-making methodologies. There just would be a little more to think through. Okay, we can come back to this when we have more open discussion. And thank you, actually, that question that you asked really set up my reminder of this bookend really nicely, that this is still an area where we are working actively. And as you noticed, even in the description of key steps, there's activity in thinking some of that through. So I encourage, again, to stay tuned. Now, I want to talk a little bit about other aspects of new research using this foundation. And I also want to highlight 2 more upcoming webinars, and then we'll open things for a more open discussion and additional questions. But this decision-making methodology described today, Dave, one of the big motivations for this was because of great potential for expansion to broader, new types of optimization objectives. Currently, one active area in developing Dave is extending it for use with data from a SMART. So I've emphasized in this webinar data from 2 to the K factorial optimization randomized control trial. We're currently thinking through the extension that would be relevant when you have data from a sequential multiple assignment randomized trial. We also are actively working to extend Dave, the method, for optimization objectives that involve equitability. We just extremely recently, days ago, had this paper come out in Prevention Science that is just introducing our initial thinking about optimization objectives that involve equitability. And here I'm meaning equitability in the outcomes of a particular intervention. So the idea that one intervention might accomplish effectiveness equitably such that participants across a spectrum of advantage are able to benefit from the intervention, whereas another version of an intervention might be effective overall, but inequitably, such that, say, for example, participants who are high SES are benefiting a whole lot, but individuals who have fewer flexible resources at their disposal are not benefiting. So our thinking is that a factorial optimization randomized control trial can illuminate some of that information as well, and that could be very useful in decision making. So this is another active area that we're working on, and happy to talk more about that if it's of interest. 2 upcoming webinars. So on February 21st, Sophie Green from the University of Leeds is going to present an application of decision-making methodologies from breast cancer. I think this is with promoting medication adherence. Mm-hmm. In this work, Sophie has done some really interesting stuff here because she previously selected an optimized intervention using a component screening approach. I haven't talked much about a component screening approach, but in that approach, you are going through a systematic screening process using individual main and interaction effects. She previously had done that and now is using Dave to select an optimized intervention with multiple outcomes now. So she'll be presenting about that. And then March 27th, we have a webinar from Dr. David Van Ness, who will be presenting about Dave and cost effectiveness analysis, and introducing these as different tools for different decisions. And this is a really important topic. In my particular example, I used time, but this y-axis could be cost in dollars. And thinking through value efficiency using dollars as a constraint has some really important parallels to the thinking that goes into cost effectiveness analysis. And Dr. Van Ness is an expert on that and will be sharing his perspective. So with that, I will pause again for more questions / open discussion involving our in-room experts and on Zoom experts.
So you can feel free to raise your hand if you'd like to come off of mute or throw a question in the chat. You can send it to me, I'm Kate Guastafaro, or put it for everybody. But as we wait for hands to raise or questions to come in, Dr. Strayhorn.
Yes.
If my next step is an evaluation RCT,
Yes.
can I use the y-hats to get an estimate of the effect size to power the experiment?
Oh boy. Yeah. So that is a great question. And I'll say that there is some complexity there, of course. I think that certainly in a simple sense, using the information from those y-hats and from the optimization randomized controlled trial to think through evaluation is absolutely crucial, and a really important part of planning for evaluation. In Dave, we use a Bayesian paradigm, and the way people in a Bayesian paradigm think about progressing from one level of evidence to the next stage of evidence building is different. It has certain notable advantages, like when information from one trial can inform priors that are used in a subsequent trial. There's even more versions of the way that information can be used in a Bayesian sense. But we also recognize that especially when people are funding evaluation trials, they might be operating within a traditional frequentist framework or needing to do a power analysis. So I do think that the information can be used. It might just take a little bit of care. And just as an example, when multiple outcomes are used to make a decision, it might be that those multiple outcomes should go into thinking about the evaluation and powering, and that is another future, hopefully not too distant future, area for us to think more about.
So it's a good transition because you mentioned here multiple outcomes.
Mm-hmm.
So on that figure that you have of Dave, the quadrants.
Oh yeah.
You at the bottom have 2 outcomes.
Mm-hmm.
How do you arrive at the value of the weights?
Yes. Another really important question. And I'll just say that there are lots of ways that people go about this. There's a large literature on multi-criteria decision analysis that can be drawn upon, and also thinking about preferences and preference elicitation. But even in a simple sense, in this particular case, I alluded to the idea that the helpfulness outcome is half as important as the treatment-seeking outcome. So even in a simple way, there can be thinking about the relative importance relative to what might be considered the primary outcome or the most important outcome. Since a lot of people are working within an NIH framework, a lot of people have to identify a primary outcome or talk a lot about a primary outcome. And in some cases, that means that it makes sense to then think about the relative importance of additional outcomes relative to that primary outcome. If it's true that that primary outcome is not actually primary, that you could also use equal weights. But there are lots of different strategies that can be used to identify these. And I'll also emphasize that one of the steps we've been using when we apply Dave is to systematically vary the weights as well to get a sense of how robust the decision might be to the choice of weights. So just incidentally, I'll note that this helpfulness outcome in this particular empirical example, there was a strong signal on this outcome. There were two factors that had really strong main effects. There were also some important interaction effects on the helpfulness outcome. But interestingly, when this information about the helpfulness outcome was incorporated, when we varied the weights all the way from helpfulness not being considered at all to being equally as important as treatment seeking, the decision was unchanged. The entire frontier here, the green line, remained the same. So it turned out that the weight that we chose a priori would not have actually changed the decision.
All right, again, feel free to raise your hand, otherwise I'll keep going, and feel free to drop it in the chat. Dr. Strayhorn, help. We are pressured to identify a single outcome. Does using a single outcome put me at a disadvantage?
Good question. So at a disadvantage, I suppose that depends on what is it, disadvantage for what. If we're thinking about the quality of the decision that's made, we have some work suggesting that when you care about multiple outcomes, particularly when you care, pretty strongly about multiple outcomes, like you might even weight them equal to one another, or even when you have one that is kind of primary, but others that are important too, there is loss when you limit your decision-making process to be based on only one of those. And so you are missing out on some information about the performance of these candidate components that could lead to a decision that's a little bit worse.
Sounds like a good tension between what reviewers and grants kind of ask for and what the science maybe calls for.
Yes, and I'll also say that it's not easy because we also can't, sometimes you'll see examples in the literature where there's a primary outcome and then there are 12 secondary outcomes, for instance. And we certainly would not think about this sort of strategy, at least most of the time. We wouldn't think about it in terms of 13 different outcomes with a value function. So there's a sort of balance to thinking about what really, really matters for the selection of an intervention. One of the ways I try to think about it is if I picked an intervention that was performing really, really, really well on my primary outcome, I'll call it, and then I found out that it wasn't really doing something else, and I was disappointed. What is that something else, and how can I factor it into the selection process?
I did see a hand raised. It went away, so I don't know. You wanna, Merrick?
Yeah, I had question like if we like after our pilot study and results has been published or like we get the result, and if we combine like A, B, and D intervention with CD, like finding the common grounds and combining both the intervention and some component of the intervention in making it more effective and less, like making it time effective and cost effective. So like, can it be done or it can be too risky to combine both intervention?
Are you referring to like intervention A, B, D, and C, D up here and saying they both seem good, so I'll combine them?
Yeah, like some component, not all can be combined, I think, but some component like which are more effective in general population or our intervention or the target audience, So can we combine it so we can have like we can see some time difference in A, B, D, and C, D. So we can like increase the effectiveness by some amount. Is it possible, or it's too risky to do?
So I'm not sure if this is going to get at your question, so tell me if it doesn't. But I have two thoughts. The first is that it might be a useful reminder that intervention. You can see my cursor a little bit.
Yeah.
So intervention ABD performed well according to these estimates. So did CD, but ABCD, containing all of them, is over here. And so this is an important reminder that sometimes adding components is not taking us in the direction that we want to go. And so this gives us evidence to, draw into that sort of decision-making process as well. However, this might also be part of what you're asking. I think it's very useful for the results of one optimization randomized controlled trial to inform continual optimization, including additional optimization trials potentially. So maybe something about what's learned about intervention ABD and what's learned about intervention CD, or what's learned about a particular subgroup of the sample or target population, maybe that would inform further questions for another randomized controlled trial, whether it's using a 2 to the K design or something else. Does that answer your question?
Yeah, thank you, Professor.
Sure thing.
Yeah, I think that was a great question to emphasize that the why we do, or what the research question is that we are working towards in the factorial experiment, and then how to use these data to answer that question, because I think it's a very easily imaginable scenario where you're like, oh, cool, the CD and ABD both did really well, so I'm just going to do it all. But if you have the data from the factorial experiment, and as Jillian points out, that dot that includes them all is no good, right? So I think that was a really great thing to hone in on. And maybe just one last question before we wrap up. Can you include a bad or undesirable outcome, like a side effect?
Yes.
Good answer.
Yes, you can. And that can be a really important example of when having multiple outcomes might be necessary. When I said before that it can be useful to think, if I pick the most effective intervention, but then I find out something else, would that change how I feel about it? That's a perfect example, because if I have a really, really, really effective intervention, but then I find out that it has an intolerable side effect, then I might not move forward with it, even if it's the most effective one. That suggests that single metric of effectiveness was not enough to capture what I needed from the intervention. So yes, you can absolutely include the side effect. The one important additional complexity there is that might mean, and this is another active area of work and consideration, that might mean that you want to use a different value function for combining your desired outcome with your undesired outcome, because there are categories of value functions that do not treat outcomes as substitutes for one another. Whereas a value function like this one that's linear treats these two as substitutes for one another, where if an intervention that's really great on the one and really not great on the other might be similar to the flip, bringing into account the weights, of course. With a side effect, the thinking about those might be more complex, and so you might just need to have a little bit more thought there.
So is a different answer to what you just said is that value function at the bottom is not the only way.
Correct. That value function is one of very, very many that could be used to combine the 2 outcomes or 3 outcomes or however many they are, just not 13 probably, to get at the metric of value.
I think we're about at time.
Okay, great. Well, thank you all for your time and attention. And if there are further questions we didn't get to, you can always reach out, but thank you so much.